Here we want to identify the horizontal and vertical asymptotes of the function using the limit definition. So to calculate a horizontal asymptote, we want to be looking at the limit as x approaches plus or minus infinity of f of x. And why is that the case? Well, if there is a horizontal asymptote, what would that look like? It's a horizontal line that the function is getting closer and closer and closer to. Okay, this function might not, look like exactly like this, but this is one way you can approach a horizontal asymptote, or it can be going like this. And what ends up happening is, as x gets bigger and bigger and bigger and bigger and bigger, f of x, meaning y, gets closer and closer and closer to the y value of that asymptote. Or as x gets smaller and smaller and smaller and smaller, meaning approaches negative infinity, the y value, f of x, approaches that asymptote. So to figure out what that asymptote is, right, what's the value that f of x is getting closer and closer to, we calculate the limit as x approaches infinity and negative infinity of f of x. So let's calculate the limit as x approaches positive infinity of 2x squared over x squared minus 4. Now I can start by asking myself what happens to the numerator and what happens to the denominator as x gets bigger and bigger and bigger and bigger, it goes to infinity. But the numerator is getting bigger and bigger and bigger to infinity, and the denominator is getting bigger and bigger and bigger and bigger to infinity. So knowing that they both go to infinity doesn't really help me. That's called an indeterminate form. So what I have to do is I have to manipulate this function a little bit so that it's a little bit clearer what's going to happen. And what I'm going to do is I'm going to multiply both the numerator and the denominator by the reciprocal of what I find the highest power of x. So I'm seeing an x squared on top and an x squared on the bottom. So I'm going to essentially divide the top and the bottom by 1 over x squared. So I get the limit as x approaches infinity of 2x squared times 1 over x squared is just going to be 2 on top. And then distributing this in the denominator, right? So x squared divided by x squared is going to be 1. And then I get minus 4 over x squared. So now things become much clearer as what happens as x goes to positive infinity, right? Because when x goes to positive infinity, 2 is just 2, 1 is just 1. And as x gets bigger and bigger and bigger, right, 4 over x squared gets closer and closer to 0. So this limit is 2 divided by 1 minus 0, which is 2. And the limit as x approaches negative infinity is the same, right? Because it's still the limit of 2x squared over x squared minus 4 is still the limit as x approaches negative infinity of 2 over 1 minus 4 over x squared. And as x is going to negative infinity, this is still going to 0, right? So this still is 2. So what I have is, since the limit as x approaches plus or minus infinity of f of x equals 2, there is a horizontal asymptote at y equals 2. Because again, this would be the y value that f of x is approaching. So now let's talk about vertical asymptotes. Well, first of all, if you have a rational function, because it's continuous everywhere that the function is defined, the only possible locations for a vertical asymptote are where the function is undefined. That doesn't mean that every place where the function is undefined is necessarily a vertical asymptote. It just means that those are the only options. So if you recall, our function is f of x equals 2x squared over x squared minus 4. So where is this undefined? So f of x is undefined when the denominator is equal to 0. So when x squared minus 4 equals 0, in other words, when x squared equals 4, or x equals plus or minus 2. Now, that doesn't mean that there's necessarily a vertical asymptote at both of those locations or at either of those locations. It just means that those are the only possible places where there could be a vertical asymptote. So how do you know if there's a vertical asymptote there? There's a vertical asymptote there if, as x gets closer and closer and closer to 2 or negative 2, y either goes off to infinity or negative infinity. But here, unlike with the horizontal asymptote, we actually have to calculate one-sided limits. So let's put this on a number line just so you can see what's happening. So here's negative 2, here's 2. When I wanted to know what happened to the function as x got closer and closer to infinity, all I had to do was start taking x's that were bigger and bigger and bigger and bigger and kind of look what happened as the function went that way. Or if I wanted to know what happened to the function as x approached negative infinity, all I had to do was, just look what happens as I go in this direction. But if I want to know what happens to the function as x approaches negative 2, I can approach from two different directions. I can start getting closer and closer to negative 2, but being over here. Or I can get closer and closer to negative 2, but over here. And if I want to know what happens to the function as x is getting closer and closer to 2, I can approach from this direction, or I can approach from this direction. So I actually need to calculate 4 different one-sided limits. So that's what I'm going to do. I'm going to calculate the limit as x approaches negative 2 from the negative side. That means from the left of f of x, which is 2x squared over x squared minus 4. So that's meaning what's happening as x is getting closer and closer and closer to negative 2 from this side. I'm going to calculate the limit as x approaches negative 2 from the positive side of 2x squared over x squared minus 4. So again, approaching negative 2, but from the other direction. I'm going to calculate the limit as x approaches positive 2 from the negative side. Okay, so that's approaching positive 2 from the left. And I'm going to calculate the limit as x approaches positive 2 from the positive side of 2x squared over x squared minus 4. So again, that's approaching positive 2 from the right, coming in like this. Okay, so looking at this first one. The first thing I want you to notice is that as x approaches negative 2 from the negative side, we're plugging in things that are a little bit less than negative 2. So think about something like negative 2.00001, because that would be less than 2, something that falls over here on the number line. If I square it, I get something which is more than 4. Okay, so something that's more than 4 minus 4. So anything I plug in over here, my denominator is going to be positive. Okay, and on top, right, whatever I'm plugging in, I'm squaring, so it's going to be positive, multiplying by 2. So anything I plug in over here is going to be a positive. So let me actually just note that. It's going to be a positive divided by a positive, because I'm approaching from the negative side. So now what's happening, right? I'm getting closer and closer and closer to negative 2. So the top is getting closer and closer to 8. And the bottom is getting closer and closer and closer to 0. Okay, but positive numbers that are getting closer and closer and closer to 0. So think about what happens when I divide 8 by something that's getting closer and closer and closer to 0, and it's always positive. That limit is going to be infinity, right? Because the denominator, as the denominator gets closer and closer to 0, remember, dividing by something is the same as multiplying by the reciprocal, so it's just going to start getting huge. So now let's see what happens as I approach negative 2 from the positive side. So things that are really, really close to negative 2, but a little bit more, something like negative 1.9999, when I square that, that's going to be a little bit less than 4. So then when I subtract 4, my denominator is going to be negative, but my numerator is still going to be positive, right? This is still getting closer and closer to positive 8. So a positive divided by a negative is always going to be negative. So now let's think about what happens when I take things that are getting closer and closer to 8 and divide by something that's getting closer and closer and closer to 0, but negative, right? Think what happens when I take 8 divided by negative 0.000001, right? I'm going to end up with something that's getting closer and closer and closer to negative infinity. Okay, so then let's follow the same logic for these two. So this is x is approaching positive 2 from the negative side. So I'm plugging in things that are slightly less than positive 2. So when I square them, I'm going to get something slightly less than 4. So all of these values along this entire approach are going to have a negative in the denominator, a positive in the numerator. So as I approach, these values are all negative. So again, this approaches 8, this approaches 0, but the values are all negative. So this must be approaching negative infinity. And over here, the limit as x approaches 2 from the positive side, I'm plugging in things that are closer and closer to 2, but slightly bigger than them. So when I square it, I get something a little bit more than 4. So this is going to be positive. So as I approach, this is going to be a positive divided by a positive. And again, this is getting closer and closer to 8. This is getting closer and closer to 0. So this limit is positive infinity. Now, I wanted to show you all of these one-sided limits because in a future video, we're going to have to graph this. But to answer the question in this problem, you actually didn't really need to know whether this goes to positive infinity or negative infinity. Because as soon as you see that as x is approaching -2, you have an infinite limit, whether it's positive or negative, you can say you have a vertical asymptote at x equals -2. And as soon as you see that you have an infinite limit, not a finite limit, but an infinite limit as x approaches 2, you can say that you have a vertical asymptote at x equals +2. If these limits came out to be a finite number, then you wouldn't have a vertical asymptote there. But because we have infinite limits, that means that we have vertical asymptotes there.